Hello student, my name is Nimish Prabhakar. I am Assistant Professor at LJ Institute of Engineering and Technology in Instrumentation and Control Department. Welcome to Process, Dynamic and Control lecture series. In this lecture, we study about heat exchanger. In my previous lecture, I complete chapter number 1. Now we start chapter number 2. So the name of chapter number 2 is Dynamic Behavior of Heat Exchanger. So in this lecture we study about basic of heat exchanger. Basic of heat exchanger. So first of all, question occur in mind, what is heat exchanger? So answer is the effective heat energy transfer between two fluids by using of equipment is called heat exchanger. That means one device that transfer energy or heat between two fluids is called heat exchanger. So now we see the basic heat exchanger and simple heat exchanger for understanding. See, this is a heat exchanger. In this heat exchanger, here cold water enter from this side and then this convert cold water into hot water by this hot water and leave from this side. And to make this cold water hot, we provide an inlet hot water from this side, and this hot water convert into the cold water after leaving this phenomenon. That means here hot water give heat to the cold water and make cold water hot. So this is a simple example of heat exchanger. We also use this type of heat exchanger in our home, like to make cold water hot. First of all, we start the flow of, this is a flow come from our tank, and this is a hot water flow. So by adjusting this hot water and cold water flow, we get our desired hot water. So this is a basic and simple heat exchanger. Here we convert cold water into the hot water, and this hot water after this completion process convert into the cold water. So the cold water give energy to the hot water and hot water give energy to the cold water. So this is a heat exchanger example. Now this is a simple example. For better understanding, we give another example like a radiator. So we see radiator in our car. So first of all, question in mind, what is the function of this radiator? So function of this radiator is to take heat of engine and to flow to the surrounding, like in an atmosphere. So the function of this radiator is to maintain the temperature of engine. So for this, it take the heat from the engine and flow to the surrounding, like in an environment. So this is a basic example of heat exchanger. Now another example of heat exchanger are like boiler. This is also the example of heat exchanger. Another example are evaporator and condenser. So these are the example of heat exchanger. Now here from this figure we understand the basic heat transmission, like heat transfer from these three phenomena. First one is conduction, second one is radiation, and third one is the convection. So by using this example, we can understand these three phenomena. So first of all, heat transfer by using a conduction. So in this phenomena, the transfer of heat or electrical current from one substrate to another by direct contact. That means because of conduction, here the handle of this device is feel hot. Like due to this conduction formula, the temperature of this handle increase. So this is a basic conduction formula. Now the radiation. Because of this heat radiation, this field, that means this device feel hot. Like energy that is radiator transmit in the form of ray or wave or particles. So this is a basic heat transmission by radiation. And third one, heat transmission by convection. So in this convection, the transfer of heat through a fluid or liquid or gas caused by molecular motion. That means due to convection, here the molecule of this water is go in a upward direction. That means the cold molecule go in a upward direction. So this is a transmission of heat energy. So by using these phenomena, heat transfer is possible. So first one phenomena is conduction, second one is the radiation, and third one is convection. So now we see the classification of heat exchanger, or in other words, the type of heat exchanger. So mainly heat exchanger classify into three categories. First one classification is based on operating principle. Second one classification based on arrangement of flow path, and the third one classification is based on design and construction. So also the operating principle have three parts. So first one of operating principle type heat exchanger is direct contact heat exchanger, regenerator, and recuperator. Also by using an arrangement of flow path, divide into three parts. That means for the first one part of the arrangement of flow path is parallel flow, second one is counter flow, and third one is the cross flow. And now design and construction is also have two parts. First one is the concentric tube heat exchanger, and second one is the cell and tube heat exchanger. Now we start with the first classification based on operating principle. So operating principle, in this we see the first type of the operating principle is the direct contact heat exchanger. So in this heat exchanger, the exchanger of heat takes place by direct mixing of hot and cold fluid, and transfer of heat and mass take place simultaneously. So the this type of heat exchanger is cooling tower. Another type is jet condenser. Now to better understand, we take one example or figure of direct contact heat exchanger. Here see, cold water is come from this side, and this cold water convert into the hot water, and to convert this cold water into hot water, we give steam from this direction, and this steam is finally is outlet from this direction, non-condensable gas. So in this, the two fluid are direct contact with each other. That means here the cold and the hot, these two are in the contact with directly with each other. So in this heat exchanger, heat take place by direct mixing of hot and cold fluid. So this is a basic example of direct contact heat exchanger. Now second one type is the regenerator. So in this heat exchanger, in this type of heat exchanger, the hot and cold fluid pass alternatively through a space containing solid particles. In other words, it also known as matrix. What is matrix? We understand by figure. So these particles providing alternative a sink and a source for heat flow. Now to understand, here this is a one heat exchanger, and the hot fluid come from this direction and the cold fluid come in this direction, and this is a matrix, and in other words we can call the solid particles. Now how this heat exchanger work? So first, here the hot water pass from this matrix. So this matrix absorb the energy of hot water, that means absorb the heat, and now then we pass this cold water. So that time this matrix release this absorbed energy. So this cold water feel hot, and this cold water converted into the hot water. So in this way this heat exchanger work. Simply they like this. First of all, this flow hot water. So this is the matrix. This absorb the heat. This is a process is known as sink. And now for cold water, this matrix act as a source. So these particles provide alternative a sink and source for the heat flow. So this is a operation of regenerator type heat exchanger. Now next one type of operating principle heat exchanger is recuperator. So in this heat exchanger, the fluid exchanging heat are on either side of dividing wall. These heat exchangers are used when two fluids cannot be allowed to mix, or when the mixing is undesirable. Like in a chemical plant, there are number of chemicals. If these two chemicals are mixed, then it is a hazardous. So the mixing of this chemical is hazardous. So for this we use this type of heat exchanger. So in this, the type of this heat exchanger is the automobile radiator or the oil cooler. Now and the air preheater. Now to understand this, we take this example. Here there is a one wall. This wall act as a divider. Like here the one fluid and here the second fluid. We consider this is a hot fluid and we give name is the A, and this is a cold fluid, we give name is the B. Hot fluid is flow in this direction and cold fluid is the flow in this direction. Now here heat exchange by this wall. That means this hot fluid transfer heat to the cold fluid through this wall. So this is a process is called the recuperator heat exchanger. So here the first is the process, this hot fluid give energy to the wall. This is a process is called the convection, and now second one is the process is the conduction, and third one process is the convection, like a cold fluid, the cold fluid and between the wall. So this is a process. So recuperator, heat exchanger. In this heat exchanger, two fluid flow in a different. That means in this heat exchanger, the mixing of two fluid is not possible because we use one wall that divide these two fluid. One fluid is flow in this and the second fluid is flow. So mixing of this fluid is not possible, and the heat energy is transferred by using this wall. So this is a third one type of operating principle heat exchanger. Now we see the classification based on arrangement of flow path. In this type, first one type of this type of heat exchanger is parallel flow heat exchanger. So as name suggests, in this heat exchanger, the two fluid, steams, hot and cold, travel in the same direction. The two steams enter at one end and leave at other end. See, the type of this exchanger are oil cooler, oil heater, and this is the figure of this parallel flow heat exchanger. So in this heat exchanger, two fluid flow in one direction. That means this is a full fluid one, cold fluid, and this is a hot fluid. These both fluid are flow in only one direction. That means the direction of flow of these two fluid is one. Like this fluid flow from this direction to this, and the hot fluid is also flow from this to this direction. So this is a simple arrangement of parallel flow heat exchanger. Okay. Now for better understanding, we see the graphical representation of this heat exchanger. Here TH1 is represent the temperature of hot water in inlet. Like here TH1, the temperature. So first the temperature is high, hot water temperature is high, and due to this heat transfer, here the temperature of hot water is reduced like this direction. So TH2 is the outlet temperature of hot water. Here the cold water. Here cold water temperature is the TC1. So inlet cold water temperature is represented by TC1, and before this heat exchange, this temperature is low because this is a cold water. And now due to this heat exchange, this temperature is increased like this, and this is a TC2. That means temperature, outlet temperature of cold water, TC2. So this is a graph of the parallel flow heat exchanger. Now second one type of arrangement of flow path is the counter flow heat exchanger. So in this heat exchanger, the two fluid flow in opposite direction. The hot and cold fluid enter at the opposite end. See, this is the figure of counter flow heat exchanger. In this figure, see, the direction of both fluid is opposite. Like hot fluid flow in this direction and cold fluid is flow in this direction. So the direction of these two fluid is opposite. Now to understand this heat exchanger, we take graph. So TH1 here, TH1 is the temperature of the inlet hot water, and this is a TH2 is the outlet water of, so outlet temperature of hot water. So this to this, so heat energy is transferred this way. like this. So first temperature is high, then due to this heat exchange between hot and cold fluid, the temperature is decreased like this. And this is a cold water. Now cold water temperature is like this TC1 here, TC1 here the inlet of cold water. So this is a low, and due to this heat exchange, this cold water is the hot water, and this is a temperature is increased TC2. So TC2 is the outlet temperature of the cold water. So here the inlet temperature is low, and due to this heat exchange, the temperature is increased by this way. So outlet temperature of the cold water is TC2. So this is a graphical representation of the heat energy transmission. Now third one type of arrangement of flow path is cross flow heat exchanger. In cross flow heat exchanger, the two fluids like a hot and cold cross one another in space, usually at right angle. To understand this, we see the diagram. Like in this, we give hot water in the tube. This is a tube that is connected in the parallelly, and the hot water flow in this tube, and we give cold water from this direction to this direction. That means this is a flow of right angle flow of this fluid. That means hot fluid flow from this direction to this direction, and the cold fluid is flow from this direction to this direction. So this is a simple arrangement of cross fluid heat exchanger. Now we start the classification based on design and construction. So first one type of this type of heat exchanger is concentric tube heat exchanger. In this type of heat exchanger, two concentric tubes are used, each carrying one of the fluid. The direction of flow may be parallel or counter. So this is an example of concentric tube heat exchanger. In this heat exchanger, one fluid is flow in tube, and that in one tube, and other fluid is flow in other tube. That means this is a cold fluid, this flow in this tube, and this is a hot fluid, this flow in this tube. So this is a concentric tube heat exchanger. So the direction of flow may be parallel or may be counter. Now next one type based on design and construction is the name is the silent tube heat exchanger. In this type of heat exchanger, one of the fluid flow through a bundle of tubes enclosed by a cell. The other fluid is forced through the cell and it flow over the outside surface of the tube. So to understand this, we take this figure. Like in this is a number of tube. This is a tube, this is a tube, and the whole arrangement like a number of tube we place in one cell. Cell is nothing but we can call as a drum. Like in one drum we put number of tube 1, 2, 3, 4. Here 4 tube is taken. So from this, one fluid is flow through a bundle of tubes. That means in this tube one fluid flow, and other fluid flow in this drum, whole drum. Like around surrounding of this tube, other fluid is flow. Like in this area, So here we see the cold fluid is enter from this direction, and hot fluid is out in this direction. So here cold fluid is flow in the tube and hot fluid is flow surrounding of this tube like this. Hot fluid is flow in this tube from this direction. Here the hot fluid is come and this hot fluid is flow like this. Here the hot fluid come and this hot fluid like a flow in this tube and the hot fluid out. And the cold fluid come from here and this flow like this and out from here. So here the in tube hot fluid flow and cold fluid flow surrounding of this tube and transfer heat energy. So this is a simple cell and tube type heat exchanger. So in this cell and type tube and exchanger, here we see the number of tubes are enclosed in a one cell, like in a one drum we place number of tube, and one fluid is flow in tubes and one fluid is flow in surrounding of this tube by this closed arrangement. This is known as cell. So these are the type of heat exchanger. Okay.